Okay, so continuing the topic, the theme of connected. Now we're now going to hear from Shyam, who's the founder of Radio Studio. Shyam, welcome. Um,
Yeah,
I'm
thanks, John.
I'm really keen to learn how we're going to evolve the connections between systems, particularly with Web3.
Sure.
Over to you.
So thanks, John, for this opportunity. So good morning and good afternoon, good evening to everybody wherever you are. I'm going to talk about how do we evolve this API landscape with the Web3 and the Web3 and the blockchain ecosystem. As we all know, that we are kind of in this transition phase from Web 2.0 to Web 3. So let me just begin by sharing the bad news, which is, well, APIs are outdated indeed. But before you fret, I mean, let me just set the context. So APIs have been around for a long, long time, we all know, and pretty much they've evolved with the Web 1 and the Web 2 ecosystem, which was predominantly client server based model. So client would send a request, API request, REST API call, right? And the server would respond with whatever the data you requested for. It's a pretty much linear one-to-one communication. This is how the internet also evolved. The HTTP protocols and majority of the internet protocols that have evolved over the last 20, 30 years, they all follow this paradigm of communication. But then if you look at Web3 from the perspective of the Web3, why I say that the APIs are outdated is because in Web3, this is not a client server based communication. This is more of a collaborator and community kind of a communication where a collaborator is talking to a bunch of community hosts, which is basically a Web3 kind of a community hosted on a blockchain network, where you don't have a single server making decisions for you. You have a bunch of nodes, and there's a consensus protocol which is running a smart contract which is making the decision for you. So in most cases, it's a one to many or a many to many form of communication, right? That happens in a Web3 kind of a application, which is very different from the traditional Web2 or even Web1 kind of a system, right? So I mean, how do we evolve to this kind of a model? In Web3, where you're talking about decentralized systems, right? So we know about decentralized apps. We hear about decentralized networks, distributed ledger, blockchain, and Ethereum and Bitcoin, and so many different things. And we have this decentralized governance as well. So this talk is all about how do we adapt the APIs to this decentralized way of building the systems. So there are four ways of looking at it that I'm going to cover. You can consider it as the four stages of API adoption in a Web3 ecosystem. So first one is the API as a data faucet, then API as a data channel, and as a data broker, and finally as a data collaborator. So let's go over each one of them one by one, and hopefully, I mean, if you guys are already uh, involved in the Web3 ecosystem, you'd probably be able to relate to some of that. But otherwise, you can probably, take it as a kind of knowledge nugget, which will hopefully help you in the future, because we are anyways going to see dominance of Web3 applications in the coming years. So starting with the data faucet. So basically, it is just like a faucet. You switch it on and switch it off, and you get a bunch of data, right? So I mean, this model of using the API is pretty similar to your REST APIs. So you have a blockchain network which is hosting a Web3 application, and you have some designated nodes in your blockchain network, which are basically the passive nodes. They are not involved in the active transactions, but they obviously have the entire history, the distributed ledger history. And you can have a REST API hosted on that, through which you can query all the raw blockchain data. So if you're talking about Ethereum, then there's a lot of interesting data you might want to look at. You might want to look at the gas prices. You might want to look at the specific transactions that have happened in the smart contract. You might want to look at the various wallet transactions. So there's a lot of raw data which is being generated on a daily basis. This is like as we say, data is a new oil. This is actually the raw oil. You can do a lot of things with this, and we can actually um, you can actually do some predictive analytics and stuff like that, where you can predict the prices, you can predict the volumes and stuff like that. So this is a very simple application where the REST APIs in their current form itself can be used as data faucets, and they can be attached to a node in a specific blockchain network. And well, you can just query the data as long as the API is working for you. So well, if you're familiar with Ethereum, and if you have any experience in developing on the Ethereum platform, then you already know a lot of websites provide this data. Etherscan is one of the most popular websites. They have an API as well, REST API. You can subscribe to that. You also have BitQuery. It's more like a crypto-focused API. You can query the crypto prices, the max, mins, and the medians, all the data that you need. You can hook up to your apps. And you also have some other platforms. For example, Spice is one of the upcoming platforms where you can run an SQL kind of a query on the Ethereum blockchain itself, to query a lot of things in terms of the blocks and the transactions and the logs and all that stuff, right? So this is the very simplistic form of application of APIs in the Web3, where you're just using them as data faucets. The next advancement comes in the form of data channel, and this is very similar to all the noise that we hear in our day-to-day lives these days, in terms of the social media channels and the notifications and all that stuff. So something like that happens in blockchain also, because when you're looking at a blockchain network, the underlying network has got a lot of data, a lot of events get generated, and some of them are system specific events in terms of the nodes and their performance and stuff like that. But then the application and the smart contract that's running on the blockchain, that also generates a lot of events, right? For example, if you're doing a crypto trading, then the price of the exchanges, and you have these upper limits and lower limits where you can set your own custom notifications. So you can have a REST API to keep querying the data, but then, as we all know, that's a fundamental problem of REST, is that it's a request response model. Whereas we do have async APIs, which are the event-driven APIs. So you can designate a block or a node on a blockchain which can actually set some rules based on certain reminders or events or system notifications. And then those notifications, when the rules are matching, can be published on that async API channels. Right. So in case of REST APIs, we deal with endpoints. In case of event-driven or async APIs, we deal with channels. So you could define those specific channels so that those channels, the users can subscribe to those channels, and then they can get a kind of a complete stream of data, based on the Web3 application itself or its underlying blockchain network, right? So these are the typical use cases. And then you have there are some services which also offer Ethereum push notification. For example, this epns.io. Then you have some platforms which are working on the layer 0 of blockchain, where they want to provide a publish subscribe kind of a real-time notification service, for the blockchain networks, which can connect the users, the D apps, as well as the nodes for various customizable notifications and alerts. And then you have several programming platforms where you can set up your own monitoring and alerts, for the underlying blockchain network, and you can define it based on your application. The next one is the data broker, which is a much little more, I would say, advanced form of data channel. So in a data channel, you are pretty much assigning, the channels as the forwarding plane for the data. Whereas in a data broker case, what would happen is that the data broker would have the semantic information about the data envelopes or the various data sets within the data, which is being pushed to a channel. And based on an advanced rule engine, you can basically propagate or forward that data envelope to individual users, right? So this concept is very similar to our GraphQL language, right? So just like in case of GraphQL, you can club multiple requests, right? So rather than, of course, we know the difference between GraphQL and REST API, wherein in REST API you have to basically, individual requests have to be pumped individually, whereas in a GraphQL you can actually club all the requests together and then put it as a request to the server. Similarly, in this case, rather than forming individual channels, you could have a data broker architecture which will have a semantic rule engine, and based on your rules configuration, you can define what data to be forwarded to which application or which user. And you could define the same rules just like your simple notification rules based on certain price alerts or certain volumes or certain indications on the underlying blockchain network or the Web3 application, right? So this is very important in the context of uh, the future of Web3, because as you know, in Web3 there's a network wide consensus that is happening in the blockchain. But then there are certain applications which are evolving where there will also be a client side consensus where the data needs to be fanned out to multiple users, especially for use cases related to DAO, the decentralized autonomous organizations, right? So in such cases, it becomes very important to have a data broker architecture like this, which can actually orchestrate the data transfer and the data propagation across multiple client devices, which are typically D apps that are part of the Web3, that particular Web3 application, right? So now coming back to the data collaborator scenario. So this is more like an umbrella scenario. This is not really uh, something which really exists in a tangible form, in the form of a platform or a specification. So in a data collaborator scenario, what happens is, again, you have a data broker which can have a semantic information about the data which is spewed out by the blockchain network, and you can actually define the rules for propagating the data. But in a data collaborator scenario, you would have something like, again, it's if I give you the analogy of the GraphQL. So in GraphQL, you can have the query operations and the mutations defined in the same place, right? So that you can perform all the CRUD operations on a typical API. You can do the mutation operation as well as the query operation. So data collaborator scenario would be something like this, where you can actually apply APIs to all the layers of a Web3 network, right? So typically, I mean, um, this is like a reference architecture, right? Where at the base layer you have the internet, and on top of that, the layer one of the blockchain, which is the blockchain nodes, followed by the consensus protocol, and on top of that you have the smart contract, and on top of that you have the DApps. So you already have a set of APIs to work on each of these layers. We also have a concept of ABI, the application binary interface, for working with the smart contracts. But when we look at a data collaborator scenario, then you would look at APIs which can kind of affect programmable consensus protocol, right? Wherein the consensus can be tweaked based on different Web3 applications. Or we're talking about creating custom bridges between multiple blockchain networks, which is already happening, by the way. And then we also have integrations across different blockchain platforms, decentralized exchanges, NFT marketplaces, right? So that is where you could actually leverage the data broker architecture to build a GraphQL sort of a query as well as a mutation kind of a logic, wherein you can tweak the underlying programmability of the network and its consensus itself, and you can build more sophisticated applications which are catering to more specific use cases. So this is what we're going to see in the next few years uh, as we move along. So yeah, so these are the you could assume that these are the kind of four stages in which the APIs can be adopted in the Web3 ecosystem. The first and the second stage, it's already being done, and thanks to the efforts in the async API specification and the GraphQL, it's already pretty seamless and pretty much possible. And in the near future, we're going to see more such integrations of APIs with the various layers of the blockchain as we evolve in this journey of Web 2 to Web 3. So finally, just to end, I would like to end with the good news that yes, even though the APIs would have been outdated, but then probably they are going to outlive at least the current era of the web. And as we move towards a Web 3, fully decentralized ecosystem, APIs would live along with them, and probably they will play a much larger role in terms of the programmability of the whole application on the internet. Right. So that's it from my side. I'm happy to take any more questions if you have.
Thanks very much, Shyam. That's a great view of where APIs, I guess, are heading, because the data faucet, more or less a one-to-one mapping to a REST style
Yes.
of API, request response style.
Yeah.
Um, and the data channel, I can see how uh, how it maps to a more event-driven type of
Yeah.
architecture. But the broker and collaborator models are certainly something that takes a little more wrapping your head around. And
Yes.
in terms of implementing the systems to support that, um, do you see are there already platforms or architectures to support that sort of model?
Yes. So you have, I mean, what we call it as an IPaaS, right? Integrated Platform as a Service. So
Uh-huh.
typically, like MuleSoft, which has an API management
Okay.
platform, all these
Yeah.
enterprise API management platforms, they have some form of implementation for this data broker.
Mm-hmm.
So they already have that. They have their own low code, no code platforms through which you can define those semantics, and
Right.
you can
Yeah.
design your own broker architecture.
Yeah. Okay. So where where to next? How soon do you think we're not going to abandon the request response style, because I think it's relatively easy to implement,
Yeah.
and um, there are many applications where you only need something as simple as that, and then
Yes.
the sort of streaming type of service um, is is uh, quite the event-driven architecture is quite
Yeah.
optimal for that style of thing. So I
Yes.
guess what it points to is if we thought things were our lives were getting simpler when the request response API came along, and then they got a little bit more complicated with the event-driven
Yeah.
style. Now we have to think about four different models for
Yep.
the type of interactions that we have between systems. Okay,
Yeah.
well, is getting complicated, but thanks for laying that out in a form that we can understand. Thanks
Yeah.
very much,
My
Shyam.
pleasure. Yeah. Thanks, John.